And the crazy part is, Netflix deploys code thousands of times a day. Thousands! Can you imagine the chaos if they were manually clicking buttons and praying?
Okay, that's a lot. I mean, I knew they were fast, but that paints a picture. But surely there's some serious automation going on behind the scenes to make that even remotely possible, right? It can't all be humans.
Exactly, and that's where GitOps comes in to save the day. We're talking about managing infrastructure and deployments entirely through Git. Think of Git as the single source of truth for your entire system's desired state.
Okay, I get the general idea. Code lives in Git, infrastructure as code lives in Git, but what happens when that desired state doesn't match reality? That's always been the sticking point for me. Like, what if someone makes a change directly on the server and bypasses Git?
That's the million-dollar question, and the answer is GitOps tools. Specifically, ArgoCD and Flux continuously monitor your infrastructure and automatically reconcile any differences. They're like tireless watchdogs, constantly ensuring that your actual state matches the desired state defined in Git.
So it's about enforcement as much as definition. Got it. But before we dive into the specifics of ArgoCD and Flux, let's really nail down why this is such a big deal. What's the real pain that GitOps solves? Because honestly, the infrastructure as code part wasn't really enough and introduced its own problems.
The pain is inconsistent deployments, manual errors, and the sheer complexity of managing modern infrastructure. Imagine you're managing a fleet of Kubernetes clusters across multiple cloud providers, like Uber does. Without GitOps, you're probably relying on a mix of scripts, manual procedures, and tribal knowledge.
Sounds like a nightmare waiting to happen. We've all been there.
Exactly. And when something goes wrong, and it will go wrong, debugging becomes a Herculean effort. You're scrambling to figure out which script was executed, who made which change, and why the production environment is now subtly different from your staging environment. GitOps gives you full auditability and traceability. Every change is tracked in Git, so you can easily see who did what, when, and why.
Okay, auditability is huge. But what about rollbacks? That's always a high-pressure situation. How does GitOps handle that?
Rollbacks become trivial. Since your infrastructure is defined in Git, rolling back to a previous version is as simple as reverting a commit. ArgoCD or Flux will automatically detect the change and reconcile your infrastructure to the previous state. Think of it like version control for your entire infrastructure.
That sounds incredibly powerful. So let's talk specifics. ArgoCD and Flux, they're both GitOps tools. But what are the key differences? And where does someone even start to choose?
Great question. Let's start with ArgoCD. ArgoCD is a declarative GitOps continuous delivery tool for Kubernetes. It focuses on application deployments. It's designed to be very Kubernetes-centric, meaning it understands Kubernetes resources natively. Think of it as your dedicated deployment robot, constantly watching your Git repositories and ensuring that your Kubernetes clusters are in sync.
So it's tightly coupled to Kubernetes. What does that mean in practice? Does it limit its usefulness with other infrastructure components?
Yes, that's a good point. While ArgoCD excels at Kubernetes deployments, it's not as versatile when it comes to managing other types of infrastructure, like virtual machines or databases. You can make it work, but it requires more effort.
Okay, Kubernetes-centric. Got it. What about Flux? How does it compare?
Flux, on the other hand, takes a more general-purpose approach. It's also a GitOps operator for Kubernetes, but it's designed to be more extensible and composable. It uses Kubernetes controllers to manage deployments, but it's not as tightly coupled to Kubernetes as ArgoCD.
So more flexible, but potentially more complex to configure.
Exactly. Flux gives you more control over the deployment process, but it also requires more configuration. Think of it as a set of building blocks that you can assemble to create your own GitOps workflows. It can handle things like Helm charts, customized configurations, and even custom controllers.
That makes sense. So ArgoCD is the batteries included option, while Flux is more of a DIY kit. But what about the actual mechanics of how these tools work? How do they detect changes in Git and apply them to the infrastructure?
This is where the magic happens. Both ArgoCD and Flux use a pull-based approach. They continuously monitor your Git repositories for changes. When a change is detected, they automatically pull the new configuration and apply it to your infrastructure.
Pull-based, so the agent lives inside the cluster, pulling config from Git. That's interesting. Why pull versus push? I would think push would be more straightforward.
That's a great question. The pull-based approach is more secure and scalable. With push-based deployments, you need to grant external systems access to your infrastructure. This can create security vulnerabilities. With pull-based deployments, the GitOps tool runs inside your infrastructure and only needs access to Git.
Okay, that makes a lot of sense from a security perspective. Less attack surface. What about scalability, though?
Scalability comes from the fact that each cluster independently pulls its configuration from Git. There's no central deployment server that can become a bottleneck. Each cluster is responsible for managing its own deployments. Think of it like a distributed system for deployments.
So each cluster is autonomous in a way. It checks Git and reconciles any differences between the desired state and the actual state. But what about conflicts? What happens if two people make conflicting changes to the Git repository?
Good question. GitOps doesn't magically resolve conflicts. You still need to use Git's conflict resolution mechanisms. However, GitOps does make it easier to detect and resolve conflicts. Because every change is tracked in Git, you can easily see who did what, when, and why.
Okay, so it surfaces the conflicts, but doesn't automatically fix them. That's fair. So we've talked about ArgoCD and Flux, the pull-based approach, and conflict resolution. Let's get into a real-world example, beyond Netflix. How are other companies using GitOps in practice?
Cloudflare uses GitOps extensively to manage their global network infrastructure. They have thousands of servers deployed around the world, and they use GitOps to ensure that all of those servers are running the correct configuration. They can roll out changes to their entire network with just a few Git commits.
That's impressive. Given their scale, I can't imagine them doing it any other way. So what's the biggest mistake that engineers make when adopting GitOps? What's the counterintuitive insight that can save them a lot of headaches?
Here's where it gets interesting. The biggest mistake is treating GitOps as just another deployment tool. It's not. It's a fundamentally different way of thinking about infrastructure management. It's about embracing a declarative paradigm where you define the desired state of your infrastructure and let the GitOps tool handle the rest.
So it's a mindset shift as much as a technology shift.
Absolutely. Many engineers try to shoehorn their existing imperative workflows into GitOps. They end up writing complex scripts and automation that defeat the purpose of GitOps. The key is to embrace the declarative paradigm and let the GitOps tool do its job.
Okay, so resist the urge to over-engineer and over-automate. Trust the tool. What else?
The other big mistake is not having a robust testing strategy. GitOps makes it easy to deploy changes, but it doesn't guarantee that those changes are correct. You need to have a comprehensive suite of tests to ensure that your changes are working as expected before they're deployed to production. Treat your infrastructure code with the same level of rigor as your application code.
Makes sense. You're still responsible for the quality of your code and configurations. GitOps just automates the deployment process. So what are 3 practical takeaways for engineers who want to start using GitOps?
First, start small. Don't try to migrate your entire infrastructure to GitOps overnight. Pick a small, non-critical application and use it as a pilot project. This will give you a chance to learn the ropes and experiment with different GitOps tools.
Good advice. Crawl, walk, run. What's next?
Second, embrace the declarative paradigm. Resist the urge to write complex scripts and automation. Instead, focus on defining the desired state of your infrastructure in a clear and concise way. Think of it like writing a recipe for your infrastructure. You describe what you want, and the GitOps tool figures out how to get there.
I like that analogy, a recipe for infrastructure. And finally,
invest in testing. GitOps makes it easy to deploy changes, but it doesn't guarantee that those changes are correct. You need to have a comprehensive suite of tests to ensure that your changes are working as expected before they're deployed to production. Treat your infrastructure code with the same level of rigor as your application code.
Solid advice. Start small, think declaratively, and test rigorously. That's a great starting point.
Exactly. GitOps is not a silver bullet, but it can significantly improve your infrastructure management practices.
So, to sum it up, GitOps is about making infrastructure changes as boring as committing code. If your deployments are exciting, you're probably doing it wrong.